Hey, it's been a while. My bad, it wasn't supposed to be. Last video I said I'd talk about why planets have rings, or how rings are formed, because obviously planets have rings because of gravity. So I guess I'll do that. It's to do with a particular feature of tidal acceleration. So what I forgot to mention, and so I put in the notes, I'm sorry, I should have mentioned it, I'm an idiot. The tidal acceleration that makes the tides go like that acts on the whole body, not just the water on the surface. That might be really obvious to you, but it's the sort of thing that I feel I ought to have said, so sorry about that. The tidal acceleration makes the entire body go like that, and so obviously it gets to a point where the material's own strength, and of course its own gravity holding it together, is overcome by the forces of gravity acting from the other mass. At which point, instead of just going like that, it goes like that and breaks apart. The point at which that happens is called the Roche limit. I've got a nice little definition here. When the body's own gravity, or material strength, is less than the tidal acceleration acting on it, the object gets pulled apart and the debris gets spread out into a ring due to varying accelerations. Because obviously, as it goes like that, some of it is closer to the mass it's affected by, and so that moves faster, and the outside is further away and therefore moves slower, meaning it goes like that. So that would be how a ring is formed. It's an asteroid or just a chunk of rock or ice or material that gets pulled into orbit and gets pulled too close to the point where the tidal acceleration overcomes the object's gravity and material strength, at which point the debris spreads into a ring because the acceleration is different depending on how close they are. The Roche limit depends on the density, so denser objects will have a higher Roche limit, meaning they can be closer. Tidal acceleration also causes volcanic activity in objects that are too far away from the sun to still retain the heat. Moons like Io, orbiting Jupiter, are stretched and compressed by tidal acceleration, and that causes friction within them, as various parts of it are jarred against the others, and of course friction creates heat. So the inside of Io is really hot because of this tidal acceleration, which is why there is molten rock and volcanoes happen. So in conclusion, differential acceleration, which is the proper name of tidal acceleration, as I'm sure you remember, is responsible for the tides, volcanic activity in moons and planets far away from the sun, and planets having rings. It's quite a useful thing to know, I feel.